Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to look at the second part of section 6.2, which covers how we can use Pascal's triangle to expand binomials. So this is kind of like a fun little puzzle. Now first off, let's look at Pascal's triangle. Okay, this is what it looks like, and there is a definite pattern on how this was constructed. Notice every single row begins and ends with the number 1. Now, how you get the numbers in between, like here to get this 2, you take 1 plus 1 to get a 2. Here, 1 plus 2 gets you a 3, 2 plus 1 gets you a 3. Every row still begins and ends with a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, start and end with a 1. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, begin and end with a 1. Now, you can use Pascal's triangle to expand binomials that have an exponent. If you have a binomial, remember that means two terms. If you have a binomial and it has an exponent of 0, your Pascal's triangle number is a 1. If you have a binomial where the exponent is a 3, your Pascal's triangle numbers are 1, 3, 3, 1. Now, this is really cool because you can use this process, and I could take something like a plus b to the power of 5. Now picture this, without this shortcut, you would have to write a plus b 5 times. So a plus b, a plus b, a plus b, a plus b, and a plus b. You can only multiply two things together at a time. So you'd multiply 2 together, multiply another group of 2 together, multiply those two products together, then you would still have your fifth a plus b to distribute. Then you'd have to combine like terms and all of those different things, okay? So that process alone could take you a ton of time, as well as probably at least a page of paper. Now, Pascal's triangle, it is a shortcut. Once you get the pattern, it goes pretty quick, and it allows you to do something like that in 2 lines. Not even kidding. So I'm going to go ahead, and this is one of those topics I think is just easier to understand when you see it done. Okay, so we're going to do 4 questions. Notice every time it is just a binomial, okay? My exponent is a 3. So if I look over at Pascal's triangle, if your exponent is a 3, the numbers that we use are 1, 3, 3, 1. So I will go ahead and write those here. 1, 3, 3, 1. The first term in my binomial is a k. The second term in my binomial is a -5. Remember, a minus sign is always tagged with whatever's behind it. So our initial setup, the first number in Pascal's triangle is a 1. The first term is a k. The second term is -5. I'm done with the 1. I add to the problem because I have more numbers left for Pascal's triangle. The next number is a 3. The first term is a k. The second term is a -5. So I'm done with that number. I need to add to the problem because I still have numbers remaining. The Pascal's number that's next is 3. Then it's k. Then it's -5. I still have another number, so I need to add to it. So 1. K, -5. Okay, so what I want you to realize at this point, the number was 3, Pascal's triangle, the numbers were 1, 3, 3, 1. That's the first thing that you will see in each term. Remember, terms are separated by plus signs, so we have 4 terms here. 1, 3, 3, 1. Next to the Pascal's triangle term, it will always be the first thing in the binomial, so the K goes first all the time. Then the second term is a -5. Now what we need to do is take care of the exponents. This is so cool. The first term in the binomial starts with whatever the given exponent is. So it gets a 3. Then in the next group, the k will get a 2. Then it will get a 1. Then it will get a 0. Now the -5 does the opposite. In the last term, it gets the 3. Then when I move forward, 2, 1, 0. And one little trick, whatever this exponent is, when you add the exponents from each piece, you need to make sure that you get a 3. So here, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Now here's your answer. You go one piece at a time and you multiply and figure out what you have. So I have a 1. K to the power of 3 is k cubed. -5 to the power of 0, anything to the power of 0 is 1. I multiply these together. That's my first term. 1 times k to the power of 3 times 1 is just k to the power of 3. Now I'm done with that piece. I go to the next piece. 3k squared Negative 5 to the power of 1 is negative 5. I multiply these three pieces together, that creates the second term. Positive 3 times negative 5 is negative 15, k squared. Go to the next term. I have a 3, I have a k, negative 5 squared is positive 25. Multiply, 3 times 25 is 75, there's a k. Go to the next chunk, 1, k to the power of 0, anything to the power of 0 is 1, negative 5 to the power of 3, negative 5 times negative 5 times negative 5 is negative 125. 1 times negative 125 is negative 125. Here is your answer. Notice like terms are already combined and it's already in standard form. 3Ks, 2Ks, 1K, no Ks. Excuse me. Okay, so hopefully that made a little bit of sense. I know that was the first example. We're doing 4. Okay, so this is kind of, I like it. It's kind of cool. To me, it feels like it's a puzzle. Let's go ahead and do it again. I have Pascal's triangle. I have to use 3, okay, because my exponent is a 3. The numbers that go with an exponent of 3 are 1, 3, 3, 1. So it's 1. The first term is 6m. The second term is negative 8. Plus, I have a 3. The first term is 6m. The second term is negative 8. Plus, the next number is a 3. Again, 6m, negative 8. It will always be in the same order. Plus 1, 6m, negative 8. You can see the 1, 3, 3, 1 in the front. The 6m is the first term, so it's the first term that comes after Pascal's triangle number. Negative 8 is the second term, so that is the last thing they will write in each piece. Now we go ahead and we add the exponents. The 3 goes to the 6m first. Then it goes to a 2, then a 1, then a 0. The negative 8 gets the 3, then the 2, then the 1, then the 0. This is a chunk. Make sure the exponent adds up to 3. It does. This is a chunk. Exponent adds up to 3. This is a chunk as well as this piece. Now I just go ahead one piece at a time and figure out what the heck I have. So I have a 1. 6, remember this power of 3 goes to both the number and the exponent. So 6 to the power of 3 is 216. M to the power of 3. Negative 8 to the power of 0. Anything to the power of 0 is 1. 1 times 216 times 1 is 216. We have m cubed. Done with that piece. 3. 6 squared is 36. M has a power of 2. Negative 8 to the power of 1 is negative 8. This is a product. We need to multiply all those numbers together. 3 times 36 times negative 8 is negative 864. I have 2 m's. Go to the next piece. 3. 6 to the power of 1 is 6. M to the power of 1 is m. Negative 8 squared, negative 8 times negative 8 is 64. Multiply the 3, the 6, and the 64. 3 times 6 times 64, that is positive 1,152 m. Last piece, 1. 6m to the power of 0, anything to the power of 0 is a 1. Negative 8 times negative 8 times negative 8 is negative 512. 1 times 1 times negative 512 is negative 512. That's your final answer and you're done. Notice all of the like terms are already combined. Standard form, 3 m's, 2 m's, 1 m, no m. So rather than having a whole page of work, it is just one line to set it up and you just do your final calculations and you're done. Okay, let's do 2 more because I want to make sure that we get it. It's one of those things that's kind of tricky, but once you get the hang of it, you guys, it goes so fast. 5, holy smokers. When you have an exponent of 5, Pascal's numbers are 1, 5, 10, 10, 5, 1. So this will be a little bit lengthy of a problem, but we got this. 1, 5, 10, 10, 5, 1. The first thing in the binomial is a positive x. The second thing is a negative 4. So 1x negative 4. Done. Plus 5x negative 4 plus 10x negative 4 plus 10x negative 4 plus 5x negative 4 plus, oh good, I was worried I was going to have to use a separate sheet of paper, 1x negative 4. Okay, so again, 1, 5, 10, 10, 5, 1. The x is the first thing in the binomial, so it's always after the Pascal number. The negative 4 is the second thing in the binomial, so it's always after the first term. Now we go ahead and we add the exponent. Now this time my exponent is a 5, so x starts with a 5, then a 4, then a 3, then a 2, then a 1, then a 0. In the last term, the second term starts with the 5, then a 4, then a 3, then a 2, then a 1, then a 0. Here are all of my pieces. I just need to figure out the value of each chunk and write it, and I'm done. As I'm separating these, you want to be able to add up the exponents. Make sure that you always get the original exponent, which for us was a 5. Now I go one at a time and I see what I have. I have a 1. X to the power of 5 is x to the power of 5. Negative 4 to the power of 0. Anything to the power of 0 is 1. 1 times x to the power of 5 is x to the power of 5. Done with the first term. Go to the second term. I have a 5. X has a power of 4. Negative 4 to the power of 1 is negative 4. You multiply. 5 times negative 4 is negative 20. X has a power of 4. Go to the next term. 10. X has a power of 3. Negative 4 squared. Negative 4 times negative 4 is a positive 16. 10 times 16 is 160 x cubed. Go to the next term. I go ahead and take 10. X has a power of 2. Negative 4 times negative 4 times negative 4 is negative 64. 10 times negative 64 is negative 640 x squared. 5x, if I have negative 4 to the power of 4, negative 4 times negative 4 times negative 4 times negative 4 is positive 256. Well, I have to now take that 256 and I have to multiply it by 5, and I get a positive 1,280. We have 1x. Last term, I have a 1. X to the power of 0 is 1. Negative 4 to the power of 5 is negative 1,024. Here is your final answer. Now, without doing this, we would have had to have written out x minus 4, 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 then multiply two things at a time, and at the end, hope that we didn't make little mistakes as we combined like terms to get this answer. Okay, last one together, and then it is a worksheet today where you get to practice this new really cool skill. My exponent this time is a 4. So when I look, this is a 4, so my numbers are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. The first term is a 3x, the second term is a 1. 1, 3x, positive 1. Done with that term. There's more to the problem, so I add 4, 3x, 1. Done with that term. There's more to the problem, so I add 6, 3x, 1. Done with that term. 4, 3x, 1 plus 1. 3x, 1. So notice I do have 1, 4, 6, 4, 1. The first thing behind them is always the first term of the binomial, 3x. The second thing of the binomial is a positive 1. That's what ends the whole thing. At this point, we need to go ahead and add the exponents. So a 4 goes to the first term, which is a 3x. So 3x gets a 4, then a 3, then a 2, then a 1, then a 0. The 1 gets the 4, then a 3, then a 2, then a 1, then a 0. Here's a chunk that will give me one term. This will give me the second term. This will give me the third, the fourth, and the fifth. Go one term at a time, figure out what we have. We have 1. 3 to the power of 4. 3 times 3 times 3 times 3 is 81. X has a power of 4. 1 to the power of 0. Anything to the power of 0 is 1. 1 times 81 times 1 is 81. X to the power of 4. 4. 3 times 3 times 3 is 27. X has a power of 3. 1 to the power of 1 is 1. 4 times 27 times 1 is 108. X to the power of 3. The next term, 6. 3 squared is 9. X to the power of 2. 1 to the power of 2 is 1. 6 times 9 is 54. 54 times 1 is 54. X squared. I have a 4. 3x, 1 to the power of 3. 1 times 1 times 1 is 1. 4 times 3 is 12. 12 times 1 is 12. And we have an x. 1. 3x to the power of 0. Anything to the power of 0 is 1. 1 to the power of 4 means 1 times 1 times 1 times 1. That's also 1. 1 times 1 times 1 is 1. That, my friends, is Pascal's triangle. Your assignment today is a worksheet. I hope you enjoyed learning this new skill, and I will talk to you very soon.